We do it 1,000 times a day, without even thinking about it. We send messages, we search for things, we watch videos, we just click, and poof, stuff appears. But what is really going on behind that screen? Today we are going to follow the incredible, invisible journey that happens with every single one of those clicks.
I mean, have you ever really stopped to think about it? You type a message to a friend, you search for a recipe, you hit play on a song, and it just works. It feels instantaneous, almost like magic. But it's not magic, it's an amazing process.
Believe it or not, that one little click kicks off this epic adventure. A tiny piece of data, a packet, travels from your device, maybe across the entire globe, to a giant computer called a server, and then all the way back to you. And this whole round trip often happens in less time than it takes you to blink. So, let's follow that data packet on its wild ride.
All right, part 1. Your digital messenger. The journey always begins right where you are, with the phone in your hand or the computer you're sitting at. This is the starting line. So this could be your smartphone, your laptop, even your smart TV. In the networking world, they call this an end device. It makes sense, right? It's at one end of the communication line. It's the place that's either creating the data you're about to send or consuming the data you're about to receive.
Now, in our story, your device is the hero, and its official title is the client. So when you open a web browser and search for something, your browser is acting as the client. It's the one making a request, basically raising its hand and saying, "Hey, network, I need some information, please."
And just to round out the lingo here, there's one more big general term: host. This is super simple. It's just any device, any at all, that's connected to a network and can talk to other devices. So both clients and servers, they're all considered hosts.
Okay, so our client, your device, has made its request. Now what? Well, the first big challenge is just getting out of the house, or, more accurately, leaving your local network. This is what you could call the first mile of the journey.
This first part of the trip has a few key players. First, your data hops onto your Wi-Fi or travels through a physical cable. From there, it gets sorted by a little device called a switch, then directed by another one called a router, before finally being translated by a modem so it can speak the language of the big, wide-open internet.
So a switch and a router, they sound similar, but they do very different jobs. Think of it like this. A switch is like the internal mail sorter in a big office building. It makes sure an email from accounting gets to someone in marketing, but it all stays inside the building. The router, on the other hand, is the main post office. Its job is to figure out the best way to send that data to a completely different network, maybe one that's thousands of miles away.
And the last stop before hitting the big time is the modem. The modem's job is so important. It's a translator. It takes the digital signals from your home network and converts them into a format that can travel over the phone lines or fiber optic cables of your internet service provider, your ISP. The modem is literally the gateway to the global internet.
And we're off. Our little data packet has officially left the building. It's now out on the open road, that vast global network of networks we call the information superhighway.
So, how in the world does it know where to go? Well, every single device connected to the internet has a unique IP address. Just think of it exactly like a postal address for a house. That address is stamped on our data packet, and it tells all the routers along the way precisely where this little piece of data needs to end up.
And what are these internet roads actually made of? Well, you've got a few kinds. Some are the classic copper cables, where data travels as little pulses of electricity. Then you have the really cool stuff, fiber optic cables. Your data literally travels as pulses of light through tiny, hair-thin strands of glass at the speed of light. And of course, there's wireless, where data just zips through the air as invisible radio waves.
Okay, after an epic journey, traveling across cities, countries, and sometimes even under oceans through those fiber optic cables, our data packet is finally closing in on its destination.
It arrives at a server. Now, if your device, the client, is like a hungry customer in a restaurant, the server is the kitchen that gets the order. It's a super powerful computer that holds the website, the video, or the game you requested, and its entire job is to serve that resource back to you.
But hold on, not so fast. Before our packet can get into the server, it usually has to get past the bouncer. That's the firewall. A firewall acts as the network's security guard. It inspects all the incoming data, checks its ID, and makes sure it's legit and not some kind of virus or hacker. It's an absolutely critical line of defense. All right, so we followed one tiny data packet on its incredible journey from you to a server. Now let's just zoom out for a second and look at a couple of bigger ideas about how these networks are actually organized.
So the trip we just followed, that's the classic client-server model. It's centralized. You, the client, ask a big central server for something. But there's another way to do it called peer-to-peer, or P2P. In this model, there is no central server. Instead, devices just connect and share files directly with each other. It's a lot like a group of friends sharing toys directly without having to ask a parent to go get the toy from a central toy box.
And here's one last cool concept for you. There's a difference between the physical topology, which is the actual physical map of how all the wires and devices are laid out, and the logical topology, which is the actual path your data takes. And get this, sometimes the shortest physical path isn't the fastest, so the network is smart enough to send your data on a different, more efficient logical route.
And just like that, the server has your request. It grabs the web page or the video file you wanted, bundles it up into new data packets, and sends them on the exact same kind of journey, just in reverse, all the way back across the internet through the modem and router in your home and right back onto your screen. It's absolutely mind-boggling that this happens in a fraction of a second.
So the next time you click something, you'll know. It's not magic. It's this incredible high-speed journey your request is taking across the globe and back again. Knowing the map kind of changes how you see everything. It's a masterpiece of engineering happening every second of every day. So now that you know the map of this digital world, where does your curiosity want to go next?